That works. Hi, everybody. Thanks for having me. It's my first time in Ukraine, so I'm visiting the country, Kyiv, for the first time. I'm happy to be here. Who's been using PostgreSQL before? Yeah, most of you guys. And who's running it in production nowadays? Yeah, some of you. And as software engineers, developers, application developers? Okay. So that talk is mostly for application developers. So I think it's going to be fine with having you guys here tonight. So, like Pavlo was saying, I've been using PostgreSQL for a long time now. Like I began last century. So it's been like 20 years and something. I developed a create extension, and so the mechanism for adding extension in PostgreSQL, it was existing before. What I added is a facility for pgdump and pgrestore to work well with extensions. I also did event triggers, and I'm now working at Citus Data. So for those of you who want to ask a question, I have some stickers as a gift for people who ask questions. So don't be shy, ask questions. I like questions. Citus Data, we are doing a sharded PostgreSQL, so it's a scale-out solution. Who knows about Citus Data already and sharding, scale-out? Okay, so the idea is that rather than having a single PostgreSQL server, you can have more than one. And each one server will have only a part of the data, not all of the data, only a part of it. And you have a first server that the application connects to, and transparently, it will route SQL queries to the servers behind it who actually have the data. It's completely open source. It's on GitHub. Citus Data is now part of Microsoft. So it's soon going to be on Azure. And so you can use that. It's completely open source. It's going to continue to be open source. So try it out if you have a need for it. I've been writing this book more than a year ago, something like that. So most of the examples that you are going to see tonight are from this book. So if you like the book, maybe you will like the book.
Which book of the link?
Thank you.
Yes.
And for those of you who want to buy it tonight, there is a discount code. It's from last week. I'm sorry about that. So it's not Ukraine specific, but I will change it, but it's too late for now. So it's yeah, it was in Concurrency last week. So anyway, otherwise, Pavlo sent me an email and we will give you a Ukraine-specific discount code. So the first question I want to ask is why PostgreSQL? So you're using PostgreSQL, you're application developers, you're writing an application, and then on the stack on production, there is PostgreSQL. So what does it do for you? Why are you using PostgreSQL? So often enough, when I have a chat with the developers, the answer I have is storage. So I have data in memory in my application. If I'm writing Java, maybe I have an object in memory, Java object, and I want to serialize it to disk, so that if I restart my application, I find it again. Okay, so storage is solved in the 60s, I think, way before we invented RDBMS. PostgreSQL has never been there to solve storage. If you want to solve storage nowadays with modern APIs, if you go on Amazon, it's called S3. If you go on Azure, it's called cloud storage. If you go extra. So if you want to solve storage and you're doing Java, maybe you could have an XML file that is exactly the dump of your object in memory, and you store your memory object in XML on file. And then when you start the application, you can read the XML file and you have an object again. Okay. So PostgreSQL is not about storage. So what is it about? It's about concurrency and isolation. PostgreSQL is all about having a single system of record, or there are many other ways to describe it, but you have a set of data that is the same for every part of your application, for every user involved. And you have a need so that several people at the same time, maybe the accountants are doing accounting, like monthly invoicing and stuff, and checking that every invoice has been paid for. At the same time that some people are ordering new stuff, and people maybe are refreshing the inventory. Maybe some items are to be ordered again, etc. And everything happens at the same time. So there are several parts of the application that are using the same data set to make decisions. And so maybe you've seen this picture before. I really like it. So it's supposed to be happening like this. Of course, in practice, it's really good. So if you want your system to look like this, well, when you use PostgreSQL, it's easy to achieve. When you use something else, it might be harder. So why is that? Well, what is PostgreSQL actually bringing on the table? It's what we call ACID. So who have heard about ACID before? Yeah, everybody. So there is no news here. So maybe I can skip that very fast. So atomic, isolated, consistent, and durable. That's it, right? Everybody knows what it's about. Well, maybe not. So atomic. Atomic means whatever you do, if you do like for your application to do something meaningful for the users, you need to do one insert and two updates. Insert, update. Let's say that in the middle of things, something goes wrong and you need to cancel what you're doing. So that's when you have a rollback. Most often, rollback is not something that the application sends to PostgreSQL. Most often what happens is that you send a commit message, but remember, a commit is one of those other queries. It's just a query. So it's something you ask PostgreSQL to do for you. So you ask PostgreSQL, please can you commit the transaction now? And maybe the answer from the commit message is going to be rollback. Like, think about it, file system is full. Everybody has that in, it happens in production. Maybe it happened to you already. If it didn't, it will, because that's what it works. And so file system is full means there is no way to commit the transaction. So your application is like insert, update, everything is fine. Commit, oh no, file system is full. So if you're using PostgreSQL, the answer is rollback. I tried to commit, it was not possible. So instead I did rollback, which is very good news because it means now that none of the insert, update made it to the database. With some other systems, you might have the insert and the first update that went through, but not the second one. Or maybe the insert, but not the two other updates. So it makes no sense for the application. And more than that, with PostgreSQL, you have transactions for DDL. DDL, you remember what it is? Data definition language. So it's a create table, alter table, etc. So why is it important to have rollback for that? Well, that's a good question. The thing is, if you have an upgrade script for your application, you have application version 1, and you're rolling in production version 2. Okay? So it's a set of scripts with new tables, new columns. Maybe you drop some columns. So you have a create table, alter table, create index, alter table again. And let's say, again, file system is full in the middle of the upgrade. If you're using something else, PostgreSQL is the only RDBMS that has transactional DDL. So if you're using anything else than PostgreSQL and your file system is full in the middle of the script, then the resulting database is not version 1 and it's not version 2. It's something in the middle. It's something that the application developers never saw. Nobody in the company ever saw the schema in production. So how is the application going to behave? Well, nobody knows. If you're using PostgreSQL and file system is full in the middle of your upgrade of the schema, well, it's a rollback. So it's back to version 1. Question?
Actually, SQL Standard but also as DDL.
Oh, full DDL, you can do whatever you want.
Yes, it's full, but most of it is.
That's fine. I will say that next time. Thank you. So maybe you can use SQL Server to some amount of it, but with PostgreSQL there is no question asked. Anything you can do, you can roll back, and that's very nice. So that's atomic. Then consistent. Consistent means you have some consistency. So usually consistency, people are talking about that, but I want to begin with the simple things, like you have a schema. Some of the other database solutions, so I like to pick on MongoDB because it's really easy to do. So MongoDB is schemaless. It's a feature for them to be schemaless. Schemaless means there is no schema. So there is no validation of anything you send to MongoDB. It's going to be happy with it. Here, we say that the table, so it's a really simplistic example. If the table foo with an ID that is an integer, but if you send banana to the ID, it's going to say, no, I don't want bananas, I want an integer. If you send banana to MySQL, and MySQL has the same schema, it will be happy to take it, and as an integer, it turns out that bananas is 0. I don't know why. But if you insert into foo the value banana, MySQL is going to take it and say, okay, that's 0. With PostgreSQL, it's going to say, no, you said you wanted integers. That's not an integer. I'm sorry. If you pick a date, for example, did you know that year 0 doesn't exist in our calendar? The calendar we have now is a Gregorian calendar. So it goes from 1 before Christ to 1 after Christ. So -1, 1. There is no year 0. In MySQL, if you put a date with a 0 everywhere, MySQL is like, yeah, that's a date. That's fine. If you put a date with like the year is 0, but you have the month and the day, I've seen customers do that. And they're like, it's a birthday, it's every year. So we don't put the year, 0 instead. Like, and you say, whatever. Sometimes they do the other way around. You have the year and the month, but you don't have the day. And they're like, yeah, it's a monthly report. You don't have a day, it's a monthly activity. It's not a day anymore. So anyway, consistency for me is first the data types. And then maybe some constraints. And I put in there relations. Some people will think that RDBMS, or Relational Database Management System. We say relation because we have foreign keys. Who thinks that's the case? It's a trick question, so yeah, maybe you don't want to do that. But it's not true, right? We have relations because in mathematics, a relation is a collection of objects, all of the same type, with the same definition and properties, a common set of properties, whatever it is. For example, integers are a relation in mathematics. Complex numbers, it's another relation that includes integers, but it's more than that. Real numbers, it's integers plus something else. Irrational numbers and things like that. So a relation is a collection of elements, all of the same type. So that's why we have the relational model. When you do that here, in PostgreSQL, foo is also a data type. It's a composite data type that has two fields, integers and text. Okay. So relational, it's part of the consistency of the model. But I'm going pretty fast because I have many slides. So if you have any questions, just ask me. I see that there is, yeah. Oh, so there are not schematics anymore.
This is different. They are actually relational and they got schema, but almost no tools to manage the schema, and it covers tons of problems.
So I need to update my knowledge of probability. Isolation. Isolation is the other side of atomic. Atomic means if you do insert a date update, either everything is taken or nothing. But it doesn't tell you if you do, like for example, the example I like is select conStar from a table, and you do it twice in the same transaction. Begin, select conStar. And then in between the two selects, someone else has done an insert and commit. Are you going to have the same numbers or different numbers, like +1? Well, it depends on the isolation level that you're using. So in the default isolation level in PostgreSQL, it's read committed. So anything that the other guy is committed, you're going to see that within your own transaction. But maybe your application needs to see something consistent for the whole duration of its transaction. Like pgdump, for example, it makes sense for pgdump to have a snapshot of the database and to not see the modifications. It's like if you look at a movie and then you stop and you see a snapshot. It's a single picture. It's not moving anymore. You know that in real life the movie is continuing. If you continue, it will change. Everything is changing at every time. But you take a picture, you have a snapshot, and you're using that snapshot. So pgdump is doing that. So pgdump used to use the repeatable read isolation level, and nowadays it's using the serializable transaction level. So it's a little complex. I won't give you the details. It's pretty well documented, so have a look at it. But maybe sometimes if you have complex concurrency scenarios to solve in your application, maybe actually all you need to do is use read committed or repeatable read instead. Okay, so that's something that is part of the standard of SQL. And do you know so durable? It's the D of ACID. It's why most people think that PostgreSQL is about storage, because we have durability. Durability means that you have the guarantee that anything that got committed by PostgreSQL, and it told you it was committed. Remember, you send a commit message, and you need to make sure the answer is commit, not rollback. Otherwise, it doesn't count. It only counts if the message that you you get back is commit. In that case, PostgreSQL is forbidden to lose the data, even if you unplug the socket. So you can write a little client that is sending data to PostgreSQL, counting in memory what it does, and during the execution of the client, you unplug the server, and then you plug it again. If you lose anything that the client has a commit message from the server, it means that there is either a bug in PostgreSQL that might happen, but it's like one of the strong features, so I would be surprised. Or most certainly, something is badly configured, or maybe you're not using PostgreSQL. So that's durability. So that's ACID very quickly for you guys. So PostgreSQL, why would you use PostgreSQL? Because we have transactions, we have SQL. So who likes to write SQL queries? I do. But yeah, some of them. So my goal by the end of this talk is that more people are going to say, maybe I should look into SQL and use it more. That's my goal. You tell me if I succeeded in that. SQL is PostgreSQL is object-oriented, and I will tell you more about what I mean with that later. But basically, if you use like the operators in SQL, like equals, if you do a SQL query where A equals B, what does it mean? Well, it means something else if A and B are integers or dates or maybe points in the geometry space or something like that. So you use the same operator always. You never think about this when you're writing this SQL. Just like A equals B, or maybe A is before B, or things like that. And SQL knows what it means, depending on the data types. So that's pretty object-oriented to me. We will see the extensions later in the talk. Data types, we have like 72 by default. If you install PostgreSQL, you have 72 data types. It's not just text, dates, integers. That's it. No, it's 72 of them. So some of them are really useful. Some of them are for the catalogs, etc. But 72 data types. We will see some about the data processing, indexing, and those are sometimes called non-relational data types because when you use that, you are not complying to the normal forms that you should normalize your schema always. But you can also have denormalization process in PostgreSQL with arrays, XML, and JSON. So that's my top list of the reasons why we are using PostgreSQL. And the first one is transactions. And what we saw before with ACID, that's a very important for me. That's you don't want to write an application and implement ACID properties yourself in the application, right? You want to use something that is good at that, and so that you have clean semantics and you can write business application. Any questions about ACID or anything here? No, I'm going a little fast, but it's on purpose. So it's okay. So some of you are not using PostgreSQL yet. Yeah, when we did the show of hands, not everybody was using PostgreSQL. So I wrote a tool that is called the pgloader. The idea is that you can migrate from something else to PostgreSQL in a single command line. It looks like this. So for example, if your production is now running MySQL, and the pgloader MySQL with a connection string to PostgreSQL. So you need to have installed created the database before. And then pgloader will have a look at your MySQL database, the list of tables, columns, data types, indexes, constraints, etc. And it will do exactly the same thing in PostgreSQL. Migrate the data over, and recreate the indexes, and redo the constraints and everything in one command line. And the only options are like connection string for MySQL and PostgreSQL. It works with MySQL, Microsoft SQL Server, SQLite, and other databases. So if you're not using PostgreSQL yet, and by the end of this talk, maybe you're like, maybe I should use PostgreSQL actually, because I will show you something. Well, just try pgloader and see what happens. The idea of pgloader is you have no excuse. Just use PostgreSQL. Of course, it's open source and it's on GitHub and it's all of them.
It supports all the versions of SQL. It supports the memory.
So pgloader, the only thing it does is ask MySQL about the list of things, objects, or catalog queries, and then migrate over the data. So it's really easy for pgloader to support many versions of MySQL.
It doesn't talk about
MySQL.
MySQL. Yeah.
like unique identifier.
Yeah. So MySQL, I don't use it every day, but try it, and if it doesn't work, open a bug report, and I will make it work. Yeah, only one month. I usually have like between 2 and 5 bugs a day, so we can have more. It's all open source, and you can even hack the solution and provide the patch. It would be cool to do that. So many of you are application developers, and most of you are using SQL. Okay, so let's have a look at SQL for developers. So we will begin with really simple things, and we will get to more complex things later. I've picked some data for New York Stock Exchange because it's open data and it was easily available, and it's easy to understand what it is. So I just picked that as an example. If you don't like it, we don't care so much that it comes from that. It's just it was easy to use. It looks like this. You have the year, the date for transactions, then the number, year, day, shares. So that's how many shares were sold that day. Then trades. So they sold that many shares in that many trades. So it's like 4 million items sold, but representing 1 billion shares, and for that amount of dollars. So we are going to first import the data in PostgreSQL. So we create a table and see it's numbers, but we say text. That's because then we're using everybody's using it's in the last line. Maybe not. Sorry about that. So it's a copy and it's a backslash copy. So who knows copy and backslash copy? Some of you. So the difference is copy in PostgreSQL. It's first it's a protocol. It's a streaming protocol. So it allows you to stream data either to PostgreSQL or from PostgreSQL. Streaming means you don't need a full network acknowledgement in between lines. So if you're writing here, we're using a facility that is provided for in the default client in psql. But you could do that if you're working in Java, maybe Python, maybe C, maybe I don't know, Ruby or whatever the language you're using. Go. You have in the driver for PostgreSQL, you have an implementation for the streaming protocol. So if you're using something like CPU hungry on the client side, and then you're injecting data on PostgreSQL, you can do it without having a round trip each time. If you do compute, insert, it's going to be very slow. If instead you do compute, copy, and you send a line each time the compute is done, you don't need to acknowledge that the line was processed in PostgreSQL. Copy is typically 10 times to 1,000 times faster than having a loop of inserts. And in that case, we're using the copy command from the client, psql, the client that goes with Postgres. So backslash copy means it's a client-side command, and we're reading the CSV file and uploading it to PostgreSQL in a streaming fashion. And there we have the data, but as text. So maybe it's not exactly what we want. But the next thing we do is we alter the table, and we replace those strings. We remove the commas, and in that case, we also substring from 2 because we just skip the first character, which is a dollar, which is not a number. So we just do a substring of replace, etc. So when you could do alter table with 3 things at once. Single table rewriting and 3 different operations in a single rewrite. You don't need to rewrite the data 3 times. 1 time is enough, and you have 3 different rewriting rules. Okay. And when you could process the text directly in PostgreSQL without having to extract the data to the client, rewrite it in the client, and send it again to PostgreSQL. See, it's very easy to do. It's one code. Another way to do it, starting with PostgreSQL 96 or 10, I don't remember. You could have here from program, and you could use a program like sed or Hawk or something like that, that would process the data and format it correctly before it's sent to PostgreSQL. But I wanted to show you that you can do alter table with many things in one command. I insist, see, it's a single alter table. There is no other command. It's a one command. Here, one command. So now we have the data, we can play around with it. When I talk about SQL to developers, the first thing they say usually is, well, when I use SQL, I know nothing about the algorithm that is going to be used by PostgreSQL, and I want to know what I'm doing. So, for example, we want the top 10 days of the whole history of the New York Stock Exchange that we just loaded. So that's the days sorted by the number of dollars sold that day. And this is the biggest day, etc., etc., and we want 10 of them. I wrote the thing in Python here. So basically, we do this query. So we fetch all the data. And then what we want to do is, we don't want to have, let's say there is 1 million lines there. We don't want to have 1 million lines in memory. Because we only want the top 10. So we want at all times 10 lines in memory, right? So what do you do when you want to do that? In Python, it's easy. You use a if queue. That's a data structure that is organized, sorted, and you can have only 10 elements. Okay? So you use a if queue, and you say, I put 10 elements in my list. I ifify this. That's the Python API. And then with if push pop, it means that you take only the 10 greatest. And the push pop means if this one is better than the one you have already, you pop the one you had and you push this one instead. Okay? So at all times in that loop, I have only the 10 top data in memory, not 1 million of them. But I have full control of the algorithm. I can change it if needs be, etc., etc. So how do you write that in SQL? Well, that's pretty easy. I'd say that maybe not all of the code is in the slide, but for real, maybe I need to fix the bug. Thank you. So go fetch. So if you find the bug, you have stickers. So find the stickers after the presentation. So that's how you write it in SQL. I think everybody can read that story, right? It's easy. Everybody has done that before. Just select from the table, order by, desk, delete that. But the question is, what is the algorithm used by PostgreSQL when you do that? It depends, yeah. But how do you know? Can you know what it does? Exactly. You explain. Thank you. That's how you do it. When you don't know what PostgreSQL is doing, you're using the explain command. And my favorite arguments are analyze, verbose, and supers, because you have many information. Beware of analysis, it means it's running the query and measuring everything that as it happens. It means that if you have a query that takes 2 hours and you do explain analyze, it's going to take at least 2 hours, right? Because it's actually executing the query. Yes, if you do a delete, that is very long. You delete because of triggers, but maybe you're missing an index. And you want to explain analyze the delete. What you do is, of course, begin, explain the delete, and then roll back. And then the delete never happened. Okay? And you have the execution plan and you can understand. So use explain as much as you need. Each time there is something that you don't know how PostgreSQL is actually doing it, you use explain to figure it out. In our case, see, sort method here. So PostgreSQL is going to scan the table, sort it, and take the 10 most elements, like the limit 10 is here. And the sort method is the top n sort. Does it ring a bell with the code that we saw before? It's the same thing, right? So basically, all the code we wrote in Python, well, it's written that way, and that's the way to check that it's actually doing the same algorithm. Okay. So as developers, we can be happy using PostgreSQL and just explain to make sure that the algorithm makes sense. And if it doesn't make sense, there are ways to tweak it maybe, or maybe you want to do it in the application anyway, but at least you know what you're doing. Questions so far? I'll just continue. Because as soon as you have that, the marketing department, or maybe the invoicing department, or maybe the financial department is going to ask you for a monthly report of the financial data. So here is a monthly report in SQL, and it's pretty easy. So again, backslash, so it happens on the client side. So in pSQL, you can set a variable, and then you use it that way with a column. And then in SQL quotes, because you want to replace the data into SQL quotes. Okay, that's easy enough. Do you know that notation? Date followed by some value. We call that decorated literal. If you're doing a Python and you have a string in your code, the string is called the literal. Same thing in Java or anything. So in SQL, if you have a string in the middle of the query, like this string here, that's a literal. Something literal. And you can decorate in SQL. You can decorate the literal with a data type, so that PostgreSQL knows the data type of the query before it runs it.
I asked this
yeah, I could have done colon start, colon date. It works.
And you can just write data as a string. How does it differ?
That is different because this happens at the parsing stage and the cast happens at the execution stage. But it's a subtle difference. The reason why I put that in the slide is because most people don't know about it, and I think it's pretty important because it allows me to say that SQL is statically typed. Before PostgreSQL is going to run the query, it needs to know the data type of the output. And what is the data type of a query? It's a relation, and so you have different attributes, and each attribute of the relation must have the data type. So shares here to char, so to string, date to date, string, string, string. Okay. So PostgreSQL needs to figure that out before it runs the query. It used to matter when you use inheritance, and then PostgreSQL might be able to prune tables in the inheritance tree. So it was the old way of doing partitioning with PostgreSQL used to be inheritance. And with inheritance, PostgreSQL needs to have the information at planning time, not at execution time. And so if you're still doing old style partitioning with PostgreSQL, then this is going to be better than casting. Otherwise, in most cases, it's stable. So my point here is just to introduce a new notation for people who don't know it, but also because as developers, data types are something that is important, usually in programming languages. Sometimes it's implicit, sometimes it's explicit. We have dynamic typing, static typing, etc. So SQL is statically typed, okay? And you can hint the planner about the types you're using. And see, I told you object-oriented. A date plus an interval, PostgreSQL knows what it means. So what is 1 month? Well, if you ask PostgreSQL without context, it will tell you it's 30 days. So 30 days, sometimes it works, but most of the times it doesn't. But if you say a date, like I picked February on purpose, February 2017, which is not a leap year. So in that case, because it's this month, then this month here, and interval 1 month is 28 days. And because I'm using less than quickly, I'm going to query for a single month. And I don't have to care about that in the application at all. Right? PostgreSQL knows about that. The trick is, if you use between, you're going to include the first and the last date. So if you do that for every month, there is one date that is going to be common every time, and so all the reporting is going to be wrong, because the same data are going to be in multiple months. The data from each day that is in between 2 months. So that's why you use greater than or equal for the start and strictly less than for the end of it. Okay. So remember about that trick. Otherwise, you have wrong reports, and then you spend like days and weeks with the accounting department, and nobody understands each other. They're like, obviously the data is wrong, and you're like, obviously the query is right, and it's ours. So it does that trick. And without surprise, you have this monthly report. Easy, right? Oh, but there is a bug. Can you spot the bug? It's tricky, so I will tell you. 19 rows. 28 days, 19 rows. So what about the days without activity? Do we want to have them in the report? Maybe not, so maybe it's okay, but mostly people are going to say, I want the calendar here, and I want whatever happened to happen, and otherwise I want 0. So in Python, it's really easy to do. You import from the calendar, and basically all the data, you make it into a hash map dictionary, and then you join against the dictionary, you probe your dictionary data is the result here. The result, blah, blah, blah. Data is fetch once, return. So you have a dictionary with the key is the date. So you go look in the dictionary if the date is in the data. If it is, you take it. If not, you put 0 in there. And you have that. I went very fast, but it's okay for everybody, right? Yeah, question about that.
Maybe it's easier to have the dimension.
To have?
The dimension of data.
What do you mean?
Like separate table for dates.
Ah, good question. So that's a very good point. So how would you do that in SQL? So I'm going to answer your question in 2 seconds. So before we solve that in SQL, what I want to say is, so if it was me, I would solve it in SQL because I know how to do it. For me, it's easy. And I prefer writing SQL than most other programming languages anyway. So, but maybe in your case, it's different. So I'm not telling you you should do it in SQL. I'm telling you, if you need to do it in SQL, here is how to do it. Okay? So you get to decide if it's important or if it's smart, in your case, to do it in SQL. That's a whole other discussion. So my discussion here is, did you know you could do it in SQL before you make a choice? Did you know it was easy to do in SQL? Because maybe the code is, you have some Java and Python application, maybe there is a quick front end running PHP here, maybe there is some Ruby code in the front jobs and by the sysadmins. I don't know. It's complex because we have the front end, the back office, the finance, the accounting dashboards, the invoicing, etc. It's maybe it's the same application because it's still a startup, but maybe it's more complex and there are many teams and each team is doing its own stuff. Maybe you need some things like that to be shared in between teams. And putting things in Postgres usually is a good way to share things. So let's do the days without activity in SQL. It looks like this. So we should have a reference table, like you said over there. Instead, in PostgreSQL, because PostgreSQL is awesome, we're going to use generate series. Who knows about generate series? Not everybody, far from that. So for those, so first thing, see, do you know what that is? Commands. SQL is code. When you write code, usually you write commands. So if you write SQL, and if you think that maybe your colleagues don't know about generate series yet, maybe you can add some comments about it. Okay. I think it's going to be the only slide with comments because usually if I add comments in my queries, then they don't fit on the side. But for this one, it was important. So generate series, exactly like the name says, it's going to generate a series of data, starting with the start up to the end of it, and with that step. So we are going to step from the first date, 1 day at a time, up to the last date. And this time, we cannot do the trick with strictly less than. So we're going to say that we take the first date plus 1 month minus 1 day. Because we're going to include the last one, because that's the API for generate series.
Negative number inside this.
You could, but then it's hard to compose. So if you do like a quarterly report, you can say plus 3 months, or you can say plus 3 times interval 1 month. So I always say, I try to always have interval 1 something, and then I have a constant multiplied by the value when I need to do that. So that it's easy to inject the constant in the query rather than rewriting inside the string. It's a trick. It's my trick. So generate series is going to generate the data, and we don't need a table for it, right? It's going to generate that in the query at runtime. And it's going to generate all the dates for the month. And it's going to know that February has only 28 days, and it's going to do that very fine. And then for each day, remember the Python code? We did probe into the dictionary if the day existed as a key. Remember that? We have the date in a hash table, and we are going to probe in the hash table if for this day in the calendar we have some data with it. Well, how did you do that in SQL? It's called a join, right? It's a left join. Whatever happens, I want to keep the dates from the generate series, and if I have some entries in my fact book, I'm going to use them. So it's a left join. And it's going to build a hash table and web exactly the same thing as we did in Python, but server side.
How will it affect the performance? Because generate series, we don't know how many rows it will return. We don't know.
PostgreSQL knows because it has all the data at planning time.
So the plan will be built correctly.
Explain, analyze it, and you tell me.
So does it create any temporal object in the?
Yes, it's going to take. In that case,
And-
it's 28 days
And
that
this
are going to
object has
be.
statistics. And this temporal object has statistics.
Say again?
This object, this temporal object,
Yeah.
that will be created by generate service.
Yeah.
Does it have?
It depends on the
Statistics?
PostgreSQL version. Usually it doesn't. In that case, 28 days you don't care, but sometimes you do. And when you do, there are some tricks around it. But I don't have time to design it here. But if you absolutely need statistics, then I would use the other techniques from the previous question, and maybe create a temporary table, analyze it, and then do the join with the temporary table.
Perhaps we can add a back condition on this table and okay.
No, because we don't have the dates in the dates don't exist in the factbook. Look at the results. This date here doesn't exist in the factbook, and we are getting the results.
First, we filter the accepted date and then we do like the join.
It's exactly what we did here. Yes, it's a good idea.
We will go each time iterate over series and make
Now,
frames.
the result of this query is in memory, and then we do the join. It's going to do exactly the same thing as in the Python code. Python code, remember, it's written that way. We iterate over the calendar, and for each day of the calendar, we go look if we have data in factbook, and we have built a hash table in memory of all the dates that we have in the book.
But you make a lookup every time.
Yes, for each row in generic series, we have to do a lookup here.
Oh, we don't have index on here.
It's in memory. We don't have an index on generic series.
On Facebook table.
Maybe we do, maybe we don't. It doesn't change anything for 28 days. For more than that, it's all dynamic in SQL. So a factbook, we have all the statistics and the index and everything. PostgreSQL is going to be good with that. It's generate series that we don't know really what's going to be out of it. So for do we need to do a hash table or a nest loop because we have an index here? It's dynamic. PostgreSQL will figure it out. So you can explain, analyze, and change the size of the table and create the index and see the impact. You can play around with it. I think there was another question.
Yeah, seems like this piece of code for generate series will run every time.
Yes.
Time.
Yes.
How is it from the performance point?
So lots of questions about performances. So I get you guys. So another answer in 2 steps. First step is semantics and what you can do in SQL or cannot. So did you know you could do that in SQL only? Who knew you could do that just in SQL? Okay. Maybe 2% of the room. Okay. So for the other guys, you can do that in SQL. So know that you can do that in SQL. But before that, you didn't know, right? So now it's possible. So I encourage you to compare with doing that in Python or whatever your programming language is, but the side was in Python. Compare the performances in Python and in SQL. And if it's like 10 times slower in SQL, let's have a look. If not, problem solved. So yes, you could have some problem with performances. But you know the performance rules from Donald Knuth? You don't care about performances until you have a problem with performances. So for now, 28 days, we won't have a problem with performances, and we can generate 28 days each time we run the query. It's going to take like less than 1 millisecond. Nobody will care. The time you need for your code to connect to the database, send the query, and get the result will be like maybe 100 times slower than generating the 28 days. There is no way you're going to see that in the map. If you think it's a concern for you, prove me that I'm wrong, and I will be happy to help you figure it out. And I don't think it's going to be great. And then if you generate a series for 100 years, and 1 day, or maybe 28 days, but 1 millisecond at a time, and you want all the milliseconds for the 28 days. Maybe it's going to be a huge data set, and maybe we have another chat about it. But for this use case, so for performances, it's always a trade-off. My point is not performances. It's did you know you could do that in SQL?
I have one question. What is L line 9, G line 9?
Yes. So look at the documentation. It's awesome. It allows you to format the data like this. So L is currency sign. Sorry. G is the separator for the thousands, and etc. And coalesce, you know coalesce? Yeah, okay. Coalesce is a function. It takes the first argument that is not new, because let join is going to generate nulls, and we want 0 instead. So coalesce. So now that we know how to do that, the next question is going to be week-on-week evolution. It's a marketing thing, week-on-week. Maybe you know what it means, maybe not, so here is what it is. I tried to pick color that matches so we can see the Wednesdays and the Mondays. So basically this Wednesday, we have 10% less dollars than the Wednesday before. Everybody can see that? Yeah. So that's your next task. Who knows how to do that in SQL?
Compare on the same days.
No, I want the previous Wednesday. I want to have the 44 billion here from the previous Wednesday. And when I'm at this Monday, I want to see the 37 here, determine that I done 3% more than last week, than the same day of last week. Yeah.
Maybe there are some already.
Yes. So here is how to write it. So maybe you recognize this as being what we had on the slide before. It's exactly the same thing. And then it's in a with query, and then we see with computed data, and computed data is in the front here. So basically, we compute that, and given that result, we're going to see last week dollars. So there is a trick. I'm going to highlight it here. We're using a function lag. Who's been using lag in SQL before? It's always the same guys. So the other guys, so lag has been introduced in the standard in 92. You know, the years of IPv6 and Unicode. So everybody knows about SQL from 92, right? No, maybe not. So if you don't know that, you don't know SQL. I'm sorry. If you've never used the over clause, lag is one of the many functions you can use, but over with the partition or the bar extra here. If you don't know how to use that, you've never seen that before. Well, the SQL you've learned is SQL from the past, from like more than 20 years ago. Okay, it was good already. It's good to know it, but you know it was like almost 30 years ago. So maybe you want to update your knowledge. And so the window function, the idea is that at any point in the query, in the result set, you are going to be able to see other rows that are called peer rows, peer, P-E-R. So you are going to be able to see other rows and do things with them. Which rows are going to be the peers? It's the frame here that defines that. So any row that has the same value here, because it's a partition, it works a little like a group by, but group is going to reduce the output. Partition is not. So it's just the visibility that we have. What are we going to see? We are going to see any row that has the same ISO from us. What is ISO? Do you know? Day of week. Day of week. So day of week, Monday is 1, Tuesday is 2, Wednesday is 3. Oh, but no, sorry. Sometimes Sunday is 1. Oh, sometimes Sunday is 0, so that Monday is 1. But sometimes Sunday is 7 because the week begins with the Monday. So, of course, there is an ISO standard to know which day is the first day of the week. Otherwise, people don't agree. So there is a standard. So ISO is the day of week from the ISO standard. I never remember which is it, but it's not important. It means that it's one of them that allows that if you have a Wednesday, it's going to be, let's say, 3. Monday, Tuesday, Wednesday is 3. And so any Wednesday is going to have the number 3. So all the rows in the results are going to be partitioned by this number. And so in this row, I will be able to have visibility on every other row that has the same day of week that I do. So I will see every other Wednesday. And not only that, but also I will see them in a given order. I will see them order by date, which allows me now to say I want to see the value that lags one behind. That's previous Wednesday. If I have a Wednesday, that's previous Wednesday.
I'm going to use lag 7.
If you do lag 7, you're going to see the row that lags given the order by 7 positions behind. So because it's only the Wednesday, and order by that, it's going to be 7 Wednesdays behind.
And then just go to partition over this day.
No, because you don't know that you have every day in the dataset.
Just can order by date and lag 7.
But look, we have rows in the dataset, so we don't know. So this guy is 7. 1, 2, 3, 4, 5, 6, 7. But I need to skip 2 of them. That is going to be a Saturday and associated with a Thursday. So we're not sure about that. If you trust your input, you might be able to do that. But here we can't. So here we extract the day of week and we partition by that. So that's a window function. And then once you have that, you can have a look at what was the dollars from the same day last week. If it was null, then null, okay. If it was 0, I don't know to compute a difference percentage with a 0 because I don't know to divide by 0. SQL is magic, but not that magic. And otherwise, I just do a percentage compute, and here is the result. It's a copy paste from the terminal. So I just run the query, and it's copy paste. I just added some colors for you guys in the site for making it easier to read. So when you could in SQL at any point in the result set have a look at another row and do some computation and compare rows in between each other. Yeah, kind of. Good. So I'm happy you were there tonight because now you know you can do it. So again, should you do it? Well, it depends. And it depends on many things, not just technical inputs. It also depends on how do you deploy that in production, and is your team going to be happy with the code review when you do that, and things like that. But at least you know you can do it. So, as I said before, the SQL Standard where we introduced window functions, it was 92. The current one is 2016. And each time there is a new SQL Standard, it means that all the previous ones are deprecated. So if you read any standard that is before SQL 2016, it's deprecated. Okay, nobody is working with that anymore. It's the past. Okay. It's easy to. I don't know if they use any. If I want to do SQL, I will not use MySQL. They you know, the whole spirit of MySQL, it's easy. MySQL, what they do is they try to make queries fast and they don't care about what they return. So they return anything. So if you do a group by, and you can return anything with MySQL. What they say is that it's the application who should care about the data, and MySQL is just a SQL engine on top of some storage. Because when I use PostgreSQL, what I want to solve first is transactions, like concurrency. What happens when there is one insert, 2 updates, and 5 selects at the same time on the same data set by different people? That's really the art of things for me. So I use PostgreSQL. So I don't know much about MySQL. All I can do about MySQL is bad things so that you don't use it. But maybe it works. I don't want to. So the current standard is 2016, and anything before that has been cancelled. And most people have been taught SQL 89 or 92, right? So maybe it's time to have another look at the SQL. So even if you're out of school this year, chances are that you've been taught SQL from 92, not current SQL. So SQL is a programming language, and how do you think in SQL? So you need to think in the declarative programming language, and you need to think in terms of relations. So what does it mean? Declarative. So if you're doing Java, C, C++, or Python, Ruby, or Go, or many of those languages, there are imperative and sometimes object-oriented, but mostly imperative. It means that when someone asks you a question, and you want to answer the question in your programming language, you need to think about the answer, and you need to write the answer in the programming language. But with all the details and all the steps and all everything. In SQL, it's a declarative programming language. It's not imperative. So you don't have to write the recipe that allows you to get the answer. You need to understand the question, and you need to write the question in SQL. So to program in SQL, you need to be able to transform the question, the business question, into SQL. So you need to understand the question well enough that you are able to write it in SQL rather than your native language. So for me, it would be French. For you, it would be Ukrainian. Some people, it's another language. But usually, that's how you talk about the question you want to answer. And then when you have a good understanding of it, you need to write it in SQL. But to be good at SQL, you need to stop trying to invent the solution. That's not your job. PostgreSQL is going to find a way to implement the query. Your job is to write the query. The query is the question, not the answer. Okay. So in Unix, we say everything is a file. Each time you want to do something, you open a file and you write or read to a file. In Java, they say everything is an object, but chapter 1 is basic. What they call that already? I think it's basic types, and chapter 2 is objects. But everything is an object. In Python, you have many things. In SQL, what do you have to think? It's relations. Relations are introduced with a select. Select is named projection operator, and it defines how many columns you have, and they call it the attribute domains in the standard, in the relational world. It means the data types of each column. And you know the word tuple? It's tuple, because if you have a couple, it's 2 of them. Triple, it's 3 of them. Quadruple, it's 4 of them. Quintuple, it's 5 of them. So it always ends with tuple, and we don't know how many of them you're going to have. So we call it the number t, like in math. So it's a tuple, it's t columns. Okay, that's what it means, tuple. So that's the select operator in SQL. It introduces how many columns you have and which data type each column will have. That's it. And then in from, you introduce relations. So let's see about a query that is interesting in terms of relations. So the from introduces relations. Decades is a relation. Oh, decades is actually a subquery that's defined here. Because the result of a query is a relation. Every query is defining a new relation. So in that query, here, I define a new relation named decades. And then I use it here. And I do a left join lateral with a subquery that is another relation, with a select that is defining a relation from. So drivers would be one relation, join results. So as soon as you do join, you are composing 2 relations and making a third one. So drivers join results, that's another relation. Join races, it's yet another relation that you're composing from pieces. And so basically this query is going to see for each decade the top 3 drivers in terms of how many times they won, as meaning the position on the grid at the end of the race was position 1. Okay, so it's the number of times they won a race by decade, and we have the top 3. It looks like this: the 50s. If anyone told you that you were driving like a Fangio, it's a very common expression in French. Like you're driving like a Fangio. It just, like some people are proud of it, but actually Fangio is the one who had the most accidents in the whole history of Formula 1. So maybe it doesn't mean you're driving so good. You're very fast, that's true, but you're breaking a lot of cars. That was Fangio. And then maybe you know about Schumacher and things like that. So here is the query that you need to write to have the top 3 per decade with the left join lateral and the subquery in the middle, just for the fun of it. It's the best way to write the query. There are other ways to write it, but did you know you could do a left join lateral and inject in the subquery? See, in the word clause, you are able to use data that is coming from the same level in the from clause as this table. That's what lateral is all about, lateral. In the subquery, I can see things from the same level of join as the other query. It's a little complex. Play around with it. Look at the documentation. Copy paste the query. Play around with it in the terminal. change the limit 3 to 1, change things, you will see what happens. So that's left join lateral with a subquery with the group by and the limit is the classic way to do a top n by category. Here the category is how many times I want to erase. It could be the top 3 articles per category in the newspaper. It could be the top 3 products that we've been studying by category on the website. It could be a top 3 of anything in a category. And then you do you fetch the category and then you do a left join lateral to inject group by limit 3 for each category. But the idea is that everything that is involved is related to the notion of relation. Okay, that's the result. Any question up to now? Oh, that's good. So I've been telling you that SQL is code, but usually when you have SQL in your application, you have either a string in the middle of your code, or maybe you are using an ORM. I don't like ORMs, but so that's a query. That's the one we used before. It's a simple one because it fits on the slide. So it's a simple. But if you have that as a string in the middle of your code, nobody is going to be happy with the review of the patch and maintaining that long term or anything. So the best thing you could do is have that in a .SQL file. So you would have, if you're doing Java, you would have files in Java.java and files in SQL.SQL. And then you can inject parameters in the query. So just a word about ORMs before I continue. The R in ORM stands for relation. And what we said before is that what is a relation in SQL? It's the result of any query. Do you know that in the standard, there is a query, there is select, everybody knows select. There is table. You can do table foo, and it will spit out all the content of the table foo. Okay? Maybe you knew that, maybe not. So table foo is the same thing as select star from foo. So the relation is the result of a query, and maybe the query is stable, but that's not a very interesting query. Or maybe it's a more complex query like this one. This SQL query introduces dynamically at runtime a new relation. And basically, ORM is going to have relations into objects. So a relation in mathematics, it means that you have a collection of objects that all have the same properties. It's easy. Collection of objects with the same properties. Maybe you've been handling that in your code before. If you're doing Java, having a collection of objects that are all of the same type, well, there are many, many different things to take care of that. In Python 2, in any programming language, it's easy to manage a collection of objects of the same type. So it's easy. You map the R, which is the result of a query, into a collection of objects of the same type. That is exactly what an ORM should be doing. Any ORM that is doing something different is going to say, well, it's very hard to map the semantics of SQL with the semantics of object-oriented programming and blah, 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 blah. It means they didn't understand SQL, and they're wrong. So some examples of ORMs that are nice are Juke in Java or POM in PHP. Another way to do it is SQL for a closure. And because it's such a great idea from Chris Jenkins, you have it in Python, PHP, and many other. It looks like this. You have a file that contains queries, and for each query you have a declaration, comments again, but they are parsed. And here, for example, this query is going to be called the function get all users. This query is going to be called select users. And then in your code, you can load the queries, and then you can get all users, and it will actually run the query that is in the file. So you can have in your code base files that are SQL, and then you just call function on them, and you can inject parameters and have the results. It's very nice to do. And then, of course, if SQL is code, you want to have regression tests on the of it. RegresSQL is something I wrote in Go because I wanted to play with Go just to see if I like it or not. If you're using something else than Go, I think it's like half a day to 1 day of programming. The idea is really easy. We have this tree, so you have some configuration, and then you have here each YAML file is a list of parameters for each query, and the queries are found in the middle of the source tree. And for each query, I will have parameters. So run this query with here is album by artist, so it could be album number 1 or artist number 2 or something like that in the YAML file. And here is when I run the query the first time, I register the expected output. So I run the query, capture the output in a .out file. And then when I change the query, I run the query again. And this time I store the result in an out file in the out subdirectory. And then I can do a diff. If it's the same file, no regression. If it's a different file, I have a regression. See, I have unit tests for SQL.
It's still using data that's from query.
Yes.
I think the same for execution system sometimes.
Yes, you could, but you need to do to use the proper options in explain so that the plan is stable. So you don't want to do explain analyze because if you inject the timing, it will always be different. PostgreSQL does that in the regression testing. Compare plans without the extra details that makes it non-stable. So yes, you can do it. And then you need the same data set, of course. And the same statistics. So it's a little complex. So SQL is code, and now we have tools. So now we have code integration in SQL files, parameters, and unit testing and regression testing. Questions about all that? How much time do I have left? I have an extra section.
-5.
Okay. So just, you can do geolocation. This reads contains, and you can make so that in PostgreSQL, you can prevent this reads overlap. So I have ranges of IP addresses, and I'm saying PostgreSQL, if there is 2 ranges that have the same IP address, I want to reject them. It's not allowed in my dataset. And then you can do a simple geolocation query like this with a KNN search. So to find all the bugs around. So it was, I used that in Dublin in the conference. So that was the IP address of the hotel in Dublin. And that was the 10, because when you speak too much, then you're thirsty, of course. And so that was the bug to go after the conference. So that's a geolocation query with a simple extension in PostgreSQL IP4R. I won't explain the details because I don't have time, but the query, in MongoDB, they have aggregates queries, no, they were really happy about that. But in SQL, we've been having them for 40 years. And they said, here is an interesting factory, but they didn't say, they didn't show the query to compute it. So I did the query in SQL, and they said it's only 1 game, but it was actually 4. So don't use MongoDB. And the last one, this one is nice because then when you run that, because we said, okay, that's 14 defensive rebounds, but what does it mean in the whole history of the NBA, that basketball? In the whole history of the game, 14 rebounds, what does it mean? Well, then you run that query that I won't explain because I don't have time, and you have this result. That's copy-paste from the terminal. And so 14 is, yeah, it's really an outsider because most of the games are between 25 and 35. You can see that. 14 is done there. And that's just a SQL query. Very easy to do. Okay, -5. I stop here. Any questions?
Yes, we will. Absolutely. You will have the slides. Any other questions? Yes. So please choose the best and
Just come see me after a while. And, yeah, I'm not good at throwing, you know.
okay, thank you. І я питаю, кого є бажання піти з нами на автопаті за свій рахунок, який-небудь папчик? Підніміть руки. От ми зараз і говоримо. 10. Добре. 11. Добре. Прошу до піци. І повертаємося через 10 хвилин. 15. 10. І продовжуємо.